right, guys. Now, after we've reviewed kind of what least common multiple is and finding a common denominator, let's use that to see how we're going to find the sum of rational expressions. Okay, so I have about 4 examples I'm going to do for you here. So you'll notice that these two denominators are not the same, 6x and 4. So if I wanted to find a common denominator for those two, okay, 6x could be written as 2 times 3 times x. And 4 could be written as 2 times 2. So my LCM, okay, I have 2 2's here, and then I have a 3 and an x. So that's going to be 2 times 2 is 4, times 3 is 12, so that's going to be 12x. That's my common denominator. So I want to change x plus 2 over 6x to something over 12x. And then I'm going to add to that x over 4, and I need to change that to something over 12x. So what do you multiply 6x by to get 12x? That's a 2. But whatever you do down here, you got to do up here. So put parentheses around that so you know that you have to put that 2 with everything there. Okay, so this is going to be 2 times x is 2x, plus 2 times 2 is 4. So 2x plus 4 over 12x. Then down here, what do we multiply 4 by to get 12x? Well, that is 3x. So we got to multiply this x times 3x. Well, x times 3x is 3x squared. Okay, now remember, when you add, you keep the denominator. So I'm going to keep that 12x. And on top, we're going to have the 3x squared. I'm going to put this in standard form, 3x squared plus 2x plus 4. I can't put any of that together. So it's going to stay like that as my answer. Now, there's one more thing you need to do, and that's to state the restrictions. This is our answer to the problem when we added them together. But now we've got to state those restrictions. So x cannot be equal to, what would make 12x, what would make that equal to 0? Well, that would be if I put a 0 in for x, because 12 times 0 equals 0. So my x cannot be equal to 0, and this here would be your final answer to that problem. Okay, let's look at number 4. Now, this time, I have an x plus 3 and an x minus 1. Okay, I can't factor either of those, so they're just going to stay like they are. That means that my common denominator, or my least common multiple, is going to be x plus 3 times x minus 1. So our least common multiple here is x plus 3 times x minus 1. So basically what we're doing here is we're taking that 4 over x plus 3, and we're going to be multiplying it by x minus 1 over x minus 1. And then plus, we're taking that 3 over x minus 1 and multiplying it by x plus 3 over x plus 3. All right, for here, we're going to get 4x minus 4. Remember, you got to distribute that 4 to both of those. So 4x minus 4 over x plus 3 times x minus 1 plus, now we're going to distribute that 3 to both of those, 3x plus 9 over x plus 3 times x minus 1. And I know I flipped the order there just to make it match what I did over here, but when you're multiplying, order doesn't matter, so it's okay for us to do that. All right, now for our answer, we still have our common denominator, x plus 3 times x minus 1. And then we're going to see if we can put anything together. 4x plus 3x is 7x. Minus 4 plus 9 is a plus 5. So 7x plus 5 over x plus 3 times x minus 1. Now, we still have to list our restrictions. So what can x not be equal to? To do that, we look back at our denominator, this common denominator we've got. What would make x plus 3 equal to 0? That would be if I put in negative 3. What would make x minus 1 equal to 0? That would be if I put in 1. So those are our restrictions, and this would be our answer. Okay, let's look at another example. X times x minus 1 plus 2x minus 1 over this. Now, this time we are going to have to do a little bit of work to come up with our least common multiple. All right, so we've got x minus 1, but now we've got to factor this one. Okay, so we got to come up with how this is going to factor. All right, if we do the diamond method, 1 times 2, that's a positive 2. And then we need to get a negative 3. Okay, so this is going to be a negative 2 times a negative 1 to give us a positive 2, and then negative 2 plus negative 1 would give us a negative 3. So it's going to be x minus 2 and x minus 1. Now, in both places, notice that we just have the x minus 1 listed one time. So our least common multiple is going to be x minus 2 times x minus 1. And if you want to, you can come right under here and put x minus 2, x minus 1 is what that is, okay? All right, now, that means that this one already has the least common multiple. It already has that common denominator. So I don't have to do anything to that one. So I'm just going to come out here and write it. X minus 2, x minus 1. But this first one, I've got to also include in the denominator the x minus 2. So we're going to do x over x minus 1, and we've got to multiply that by x minus 2 over x minus 2. All right, so for here, that's going to be x squared minus 2x over x minus 1 times x minus 2. And then we're adding to that this 2x minus 1 over x minus 2 times x minus 1, because I didn't have to do anything with that one, okay? All right, now we can put things together. X minus 1, x minus 2, that's our common denominator, so we're bringing it down. And remember, order doesn't matter. All right, x squared, there's not another x squared over here, so I'm going to keep that. Negative 2x plus 2x, those cancel each other out. And then we've got minus 1. Now, hopefully you recognize that this is a difference of squares, which means I can factor it as x plus 1 times x minus 1. And we're still over our common denominator. The reason you want to do that, if it will factor, is because look here, this takes us back to simplifying expressions. X minus 1s will cancel, so we're just left with x plus 1 over x minus 2. And this would be our answer. But we still have to list our restrictions. What can x not be equal to? Remember, you go back to your common denominator to see what x can't be equal to. So what would make x minus 1 equal to 0? That would be a 1. What would make x minus 2 equal to 0? That would be a 2. So this would be our final answer for that one. Okay, I'd like for you to pause the video and see what you can do with number 6, and then come back and I'll work it. Okay, hopefully you pause the video and you work number 6. So let's look at x squared minus 4. That will factor to x plus 2 times x minus 2. And then you have an x plus 2. So we've already got the x plus 2 in this one, but it still needs the x minus 2. So that means I've got to multiply the top and bottom here by x minus 2. But this one here, you can mark through that, and it already has the common denominator, x plus 2, x minus 2. Okay, so what we've got here is x over x plus 2 times x minus 2 plus, okay, now we got to multiply here. 1 times x minus 2, that's going to be x minus 2, over our common denominator, x plus 2 times x minus 2. Now we're going to add x plus x, that's 2x, and then we've got that minus 2 out there, over x plus 2 times x minus 2. Now, these both have a 2 in common. So if I took out a 2, that would be 2 times x minus 1 over x plus 2 times x minus 2. If you finished with this one, it would be okay, because even though I could take out a greatest common factor, it doesn't help me to cancel anything out. So I didn't really accomplish anything by taking out that greatest common factor, but I needed to check just to see. So if you left it as this answer, it would be fine. So we'll circle this one as our answer. And I left some room down here because we got to say what x is not equal to. All right. X plus 2, in order for that to be 0, it would have to be a negative 2. And x minus 2, in order for that to be 0, it would have to be a positive 2. So our x cannot be equal to positive or negative 2. All right, guys, as always, if you have questions, let me know. I will tell you this, the practice problems, some of them already have common denominators. So if you already have a common denominator, you're just going to be adding your numerators. You're already at this point, and then just keep your denominator. Let me know if you have any questions.